Hello and welcome to lesson 8.2, solving square root equations. Today we're going to work on two targets, solving square root equations, and identifying extraneous solutions. The word extraneous means not needed. Okay, so we might solve an equation and get an answer that seems to make sense and it makes the equation true, but then when it's plugged back in, the value makes a denominator equal to 0 or it creates a negative radical, and those are all things that are not allowed. So we have a 4-step process for solving our equations that contain square roots. Step 1, isolate the radical term. We want to get the radical term all by itself. Step 2 will be to square both sides of the equation. Step 3 will be to solve for the unknown. And finally, step 4 will be checking for the extraneous solutions. So a couple of the examples are here, and I'm going to go past those to try a few in the try these set. Okay, so you'll see 4 radical or square root equations here. Some of them have powers to the 1/2, but those are still square roots. And we'll go through a couple of those. We'll start with part A. In part A, we have 2 minus the square root of x plus 1 equals -5. We want to start by isolating the radical. We want to get the radical all by itself on its side. I'll begin by subtracting 2 on both sides. That leaves negative square root x plus 1 equals -7. Then divide by -1 on both sides. The square root of x plus 1 equals 7. Okay, so the square root has been isolated. Your next step will be to square both sides of the equation. Doing that will remove the radical. X plus 1 equals 49, which means x is 50. X is 48. We're subtracting. Next is to check the solution. So if we plug the solution back in, we should hopefully get a true equation. Well, I'm going to plug in 48 into the radical right here. And I will see 2 minus the square root of 48 plus 1 equal -5. Is that true? Well, 2 minus the square root of 49 is 2 minus 7. That is true. So we do have a good answer. X equals 48. Part B, we have the square root of x plus 4 equals x minus 8. This time we have a binomial on the right. And when we go in to square both sides, since it's already isolated, we can go right to that step. We're actually squaring a binomial. Be careful there. We'll pull out the x plus 4, but now we have x minus 8 times itself, x minus 8. X plus 4 equals x squared minus 16x plus 64. We have a quadratic equation. And to solve a quadratic equation, we want to set it equal to 0. 0 equals x squared minus 16x. And then, nope, it's going to be minus 17x if we subtract x on both sides. And then subtract 4, we get plus 60. We'll try factoring. If that doesn't work, we'll try quadratic formula. So the 60 has a lot of factors. However, I think it's the 12 and the 5 that will make the -17, which means we get two solutions. X equals 12 and x equals 5. Now they may both work, they may not. We're going to have to check them. I'll start by checking 12. So 12 plus 4 is 16. Square roots out to 4. And 12 minus 8 is also 4. That one checks out. 5 plus 4 is 9. And the square root of 9 is 3. 5 minus 8, though, is -3. That one does not check out. That one is extraneous. Okay, it came out, you solved it right, but it just doesn't check. So we'll put that one over there. Just the 12 checks out. Okay, we'll try one more. We're going to try part C. With part C, we have the square root of x plus 6. And I like to write that as an actual square root. I'm going to put it in a root instead of a 1/2 power. It means the same thing, but I like to see it in that form. So now I can actually square both sides, which will leave us with x plus 6 equals x squared. It's another quadratic. We'll set it equal to 0, x squared minus x minus 6. And when we factor, we get -3, positive 2. I'll double check that. -3x, positive 2x. Looks good. So again, two solutions. X equals 3, x equals -2. We do want to check them both. We'll start with 3. 3 plus 6 is 9. The square root of 9 is 3. But on the other side, we have -3. That one actually doesn't work. That one's extraneous. Now let's try -2. -2 plus 6 is 4, and the square root is 2. Okay, negative times -2 is also 2. That one checks out. X equals -2 is the only solution that will work there. And that's basically how we solve a square root equation. We can also solve them on a graph. That's one thing we could do. If the numbers are small enough, we could graph them by hand. Otherwise, we'll look at one where we can graph it on your graphing calculator when we get in class. But this one we can probably graph by hand without too much trouble. There are two sides to this graph. One side we're going to be graphing will be the side y equals 2 times the square root of x plus 4. And on this side, we're going to be graphing y equals 6, and that's an easy one. Y equals 6 is just the line that goes right through there. So basically, we're going to be looking for where our graph actually crosses that line, and where it crosses that line is where will be the ordered pair that they share. That will be the solution. So let's take a look at, we remember how to graph a square root function just based on the parent function, okay? But we know we're going to have to shift everything to the left, so we'll have to go to the left 4. Okay. And then we're going to have to stretch it by a factor of 2. So we're going to go left 4, and we're also going to have to stretch or do those, do that multiplier of 2. So typically we're at 0, 0, but we're going to have to go left 4, 1, 2, 3, 4, and then times 2, which is still 0. If I put in a, let's say, how about a 1 gives me a 5? That's not a good one. We could put in a 3, 4, we could put in a 5. 5 will give you 9. Square root is 3 times 2 is 6. So over 5, and then we're up at 6. Oh, we found it. It's going to be right there. And anything in the middle, you could also check out numbers like, -3, will give you 1. And then 1 times 2 is 2. So like -3 would give you up here at 2, So that'll help you get a graph, and then you'll see where it crosses. It's actually crossing at over 5 and up 6. So our ordered pair in common would be 5, 6. So x equals 5 would be the solution. Okay. And then in class, I'll show you how to do the one on the next page that's got a little bit bigger numbers, and we can figure out how to look at it graphically as well. All right, for assignment